Question of the Week from the Naked Scientists.
Are you ready for this week's Question of the Week? This is me, Kerstin Gepfrich, and I warn you, hold on tight for the question we'll send in.
How can newly produced photons travel at the speed of light instantaneously without causing a force in the opposite direction? Why don't I get thrown backwards when I switch on my torch?
To shed light onto this question, I dug out my torch and made my way to the Nanophotonics Center in Cambridge, where I met with Dr. Anna Lombardi. Anna, can light exert a force to move a physical object?
Yes, definitely. According to Newton's second law of motion, a force is the mass of an object times its acceleration. But light is weird. It travels at constant speed, the speed of light. It never accelerates. In addition, light is made of photons, which don't have any mass. The crucial point is that, while light doesn't accelerate and doesn't have mass, it does carry a momentum. And momentum, as a form of energy, can be transferred. By transferring their momentum, photons are able to exert a force on an object. Physicists refer to it as an optical force. The higher the frequency of the light, the larger its momentum, and therefore the stronger the force it can exert. This means that blue light will push you stronger than red light.
The theory tells us that light does have a little bit of a push, but I certainly cannot feel it when I switch on my torch. What's the point of all the theory then?
While the push of light is so tiny that you don't feel it in everyday life, we can observe it at the nanoscale, in the world of the infinitely small. Arthur Ashkin, a scientist working at the Bell Labs in the 70s, demonstrated that nanometer and micron-sized particles can be accelerated, trapped, and manipulated by the radiation pressure of a highly focused laser beam. Nowadays, scientists use light quite literally like optical tweezers to manipulate objects from cells to single atoms.
Does that mean we just need a superpower torch to move the big stuff?
If, as a light source, we don't limit ourselves to a simple torch, but we consider the sun, then the radiation pressure exerted is strong enough to push spacecrafts and even asteroids from their path.
So you better know the math when you plan your next mission to space. But Matt, I think we're safe to turn the torch back on. Thanks for your question, and thank you, Anna, for the answer. And next time, we'll be answering Tim's question.
If you start with a magnet with a north and south pole and break it into half, you get two separate magnets, each with their own north and south poles. So how does it know it's been broken? What causes the change? And where does it get the energy to do this?
Do you know the answer? Tweet at The Naked Scientists or get in touch on our Facebook page on the forum nakedscientist.com/forum or email chris@thenakedscientists.com with ideas and new questions. This was our Question of the Week. Thanks for listening.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.